Hello, 8th grade! So today we're looking at lines of best fit. So a bit more of what we were doing in the last section, but now we're adding a little bit onto it. And I realized when I was uploading the last video that you can't always see the grid lines on the back all that well on the camera when I'm drawing on them. But the dots are the important thing, so hopefully that part at least is coming through. So I went ahead and drew my own graphs, even though the back of the whiteboards have graphs, because you can really see them anyway. Now, some of these, the graphs will already be there for you. Some of them you're going to have to go through and graph the points, but I'm assuming that's not going to be the hard part, because you guys have been graphing things for at least a couple years now. If you want me to go through and do a few examples of graphing points, I can. I'm just not going to clog up this video with that. If you want me to do a video of that, that's fine. I'm assuming most of us are okay on graphing points at this point. Pun intended. Okay, so let's say we've got this graph here. And I want to draw a line of best fit. So what I'm looking for with a line of best fit is a line that goes through or close to most of my points. Now what you don't want to do is you don't want to go through and play connect the dots and connect them all one by one, because the next thing we're about to do is we're about to write an equation for this line, and we don't know how to write an equation for a line that's going squiggle, squiggle, squiggle yet. We don't have that yet. So we know how to write equations for straight lines, so that's what we're going to draw, even though it's not going to go exactly through all of our points. The idea here is to get close enough. So I want something that's going to be close to most of our points. And in general, if it's something that would make sense in this situation, it's a good idea to try to graph it through 0, 0 if you can, because then your equation's going to end up a bit simpler. For example, if you're buying cookies and we've got the number of cookies and the price of the cookies, it makes sense that even if it's not on here, 0, 0 would be a point on that graph, because if we don't buy any cookies, we don't have to pay for any cookies. So if it would make sense to go through 0, 0, that's going to make it a bit nicer in a moment when we go ahead and find the slope and the y-intercept for that. It's going to make it easier to write an equation. So I'm going to go ahead and go through that point. And again, we just want to draw a straight-ish line through or close to most of our points. So it looks like one of my points got erased up there. That's okay. My cat sat on this board. There we go. Okay. So, pretty close. So we got some that are above, some that are below, but it's going exactly through a couple of them. We got this one here that is going exactly through. We got this one here, it's going exactly through. And these others that is pretty close to. So, close enough. So all of these are going to be making predictions with these. So if you're looking at your numbers and you're double checking your numbers in the back of the book to make sure you got it right, it's okay if your numbers don't come out exactly the same as the ones that are there. We just want to be in the same ballpark. So it's okay if those numbers aren't exact, or if you're texting someone else and saying, hey, what'd you get for such and such number? It's okay if you didn't get exactly the same thing, because you probably didn't draw exactly the same line. There's more than one line that would be okay here, so as long as we're in the same ballpark, we're good. Okay, next thing we're going to do with this is we're going to write an equation for the line we just drew. Now, think back to when we were doing lines before. If we have a nice straight line like this, the equation we're using looked something like y equals mx plus b. Now, you probably already have that in your notes somewhere, but if you don't, or if you're not sure where it is because all of your notes are at school or something, then you might want to jot down that m is your slope, and b is your y-intercept, which is why it's nice, if you can, to go ahead and draw this going through 0, 0, because that makes our y-intercept 0. Yay, we just made things a whole lot easier for ourselves. So now we just need to find our slope, because our y-intercept is 0. And the other thing you might want to jot down somewhere if you don't have your notes handy is that slope is rise over run. And I just erased that. There we go. Rise over run. So slope is rise over run. Now in order to find our slope, I'm going to go ahead and pick 2 points that are pretty close to this line. And again, it makes sense to use 0, 0 if you can. So I'm going to use 0, 0 as one of my points. And I'm going to use this one about here-ish. I don't know if you hear my cat in the background there. Okay, So this one's about 15, 4 point something. We're going to call that 5. Because 5 would be about here, but close enough. Calling it exactly 5 is going to make it a little bit easier to deal with, so I'm just going to go ahead and call that exactly 5. So we're going to call that 15, 5. So then our slope is our rise over run. So if we're going up from 0 to... Whoa, there's my cat. Okay. Hang on. Kitty. Kitty. You need to get off now. I'm making a video for 8th grade. There we go. Sorry about that. I could edit that out, but I think it's probably more entertaining to just leave it in. Okay. So we've got our slope here. Slope is rise over run. So I'm going up from 0 to 5. We're rising 5. And we're running 15 because we're going from 0 over to 15. And I know some of you like decimals. I'm going to leave that as a fraction. There's a reason I'm going to leave it as a fraction. So if I leave that as a fraction, but I'm going to go ahead and reduce it. So we're going to divide by 3. We're going to divide that by 3. We're going to divide by 5, and we're going to get 3. Sorry about that. My bad. So we're going to divide by 5. We're going to get 1, and we're going to get 3. So our slope there is 1/3. I'm going to grab an extra clipboard. Figured out. Probably run out of room there. Okay. So right now we got our slope is 1/3. So then our equation, if we're plugging that into y equals mx plus b, our equation is this y equals 1/3. This is going to stay in x. And we already said b was 0, so if you want to go ahead and stick a plus 0 on there, you can. It's not going to hurt anything. It's also not really going to do anything, so I'm just going to leave it off. So we get y equals 1/3 x. There's our equation. Now the last thing we're going to do with these is we're going to use it to make some predictions. So let's say we want to predict how much let's say 60 cookies would cost. Now, the ones we were looking at before, if we're making predictions, we could just go look at our graph and look at our line and say, oh, well, that's where it crosses our line, so that's our prediction. But our graph doesn't go up to 60, so now we're going to have to do something else. So our cookies were our x. Our money was our y. So if I want to predict how much 60 cookies cost, we're just going to take that 60 and we're going to go ahead and plug it in for x. So we got 1/3 times 60, and 1/3 of 60 is 20. And that was in money, so I'm going to stick a little dollar sign in front of that. Now, just a heads up that if you change that to a decimal and rounded something somewhere and therefore got something slightly different, that's okay. Again, we're estimating, so we just want to be somewhere in that ballpark. So somewhere around 20, 18, 19, 20, 21, 22, somewhere around that ballpark, that's fine. So if you didn't get exactly 20, not a problem. We just want to be somewhere in the right general area. So that is what we are doing with those. I'm going to go through a couple more examples here. Now, I said earlier that if it makes sense to go through 0, 0, go for it. There are going to be cases where that doesn't really make sense. For example, if we've got something where we're starting up here and we're going down, we probably don't want to throw 0, 0 on there as a point. That wouldn't really make sense. If I'm graphing, say, minutes and my miles that I am away from home, maybe I'm biking or driving or something. So if I'm graphing that, I probably don't want to start at 0, 0 because that would mean we're already home and we're going in a general this way direction. So the other thing you want to do then, if you can't start at 0, 0, if that doesn't make sense, go ahead and start at something that's a nice point. So in general, as we're going up here, I'm going to throw a point on here at 40. Now maybe it's not exactly 40, maybe call it like 38, 39. I'm going to call that 40 just because it's going to make it a little bit easier if we called that our y-intercept. And then I'm just going to draw a line going like this-ish. And going along that way. And again, there's more than one line that would be okay. So if you didn't draw exactly that line, that's fine. If you don't get exactly the same equation or exactly the same answer because of that, that's okay. We just want to be somewhere in that general ballpark. So then if we want an equation for that line, same sort of thing, y equals mx plus b. The only difference is this time our y-intercept isn't going to be 0. So this time our y-intercept is going to be somewhere around 40, but that's b. I actually want my slope first. So I'm going to say I have a point here at 0, 40. And I go through a pretty nice point over here at 4 and about 30-ish. So if you want to use that, that's fine. Or we went through another one over here at 14 and about 20-ish. Now, depending on which one of those you use, you're going to get slightly different things, and that's okay. So I'm going to go ahead and use that 1421 and that 431, just because if we go from x to x there, that'll give us a nice 10 to divide by if we're going from 4 up to 14. Okay, so if we're looking for our rise and our run, now watch out for if you're going down, your slope is going to be negative. So whatever our rise is, we're actually falling. So we're going down. So if we're going down from 30 to 20, well, that's 10. So we're going down 10. And we're going over from 4 to 14. So we're going over 10. And if those aren't nice numbers that you're going to be able to see off the top of your head, the other thing you could do is you could take that 14 minus that 4, and that'll also give you that 10. Okay. And nicely, negative 10 over positive 10 is just a negative 1. So I'm just going to call that negative 1. And that's x plus. Okay. And now we're up here at 40. Again, ish. So we just want to be somewhere in that general ballpark, and if you didn't put that 1 on there and just call that a negative x, that would also be okay. So it's okay if it's there, it's okay if it's not. We just need to watch out for that does need to be a negative. So then we want to know, what if I want to know how far am I from home after, I want to make a prediction after about, say, 25 minutes. Okay, minutes is x, so we're just going to take that and we're going to plug it in there. So y equals, and don't forget about that negative. Negative 1 times 25 is just negative 25 plus 40. And negative 25 plus 40 is a positive 15. And that was in miles. Now, the other phrase you'll see a bit of is interpret the slope and the y-intercept. So sometimes when you're writing your equation, you'll say interpret your slope and your y-intercept. That just means, what does that number mean? So what does that 40 mean? And if we're looking on our graph, what that 40 means is we're 10, 20, 30, 40 miles away from home when we started. So your y-intercept is where did you start? And then our slope, if we're looking at our slope, and our slope is negative 1, we're getting 1 mile closer to home for every minute we're going this way. So that phrase, interpret the slope and the y-intercept, just means, okay, what do those numbers mean in terms of what's actually going on in your word problem there? So if you see that phrase, that's what that means. Okay, one more. Let's say I've got some heights. So I've got some ages of, well, some kids, because these are like 6 to 8 year olds, and their height in inches. And again, we want to draw a line of best fit. We want to make a prediction about, let's say, prediction about what's happening at 20 years. Okay. So first thing we want is that line, and again, there's more than one line that would be okay. So we just want to try to go through most of these points. So I'm just going to draw a line going like something like that. Again, if you didn't draw that exact line, that's okay. You just probably won't come up with that exact graph or that exact equation or the exact same answer, and that's okay. So I feel like I'm repeating myself a lot here, but if you're looking in the back of the book, because you're double checking your answers, not because you're looking at the answers, if you're looking in the back of the book to double check your answers and you didn't get exactly the same thing, that's okay. Which also means that if you did get the exact same thing as the back of the book, that's kind of suspicious there, and I'll know that you got the same answer as the one in the back of the book. Okay. So, anyway, what was I saying? So, we want an equation for this line, so y equals mx plus b. Okay, so we've got our slope, and again, you want to pick 2 points that are pretty close to your line here. So I've got one here at about 8 and about halfway between 40 and 50, so we'll call that 8:45. And we've got one at about 16, let's say 65. And again, if you pick 2 different points, you'll get something slightly different somewhere in that ballpark. So if we want our rise, if we're going up from 45 to 65, nice numbers, that's 20. And if we're going over from 8 to 16, that's just 8. And again, if those aren't nice numbers that you can see off the top of your head, well, if I'm going from there to there, that's 8, we just go ahead and subtract those. So 16 minus 8 gives you 8, 65 minus 45 gives you 20. And then we're just dividing those. 20 divided by 8 gives you 2.5. And this time I'm going to turn it into a decimal just for fun. So, last one I left as a fraction. This one you can turn it into a decimal. If you left it as a fraction and reduced it to 5/2, that would also be okay. This one's going to come out to a nice decimal, so I'm going to go ahead and call that a decimal. So I got y equals 2.5 x plus, and about 30 is where we ended up there. And then if I want to make a prediction about what's happening at 20 years, I'm going to grab some more space here. These get kind of long. So if I've got y equals 2.5x plus 30, and I want to make a prediction about what's happening at 20 years, we're going to take that 20 and plug it on in and say y equals 2.5x plus 30. X is now 20. And 2.5 times 20 is 50. 50 plus 30 is 80, and that was in inches. Now, this one's actually a good example of when your prediction is only going to be good for so long after your actual graph. Now, if we're graphing something like the cost of cookies, that's probably going to stay pretty steady. But if you're graphing your height over a period of years, yeah, for a certain period of time, it's going to keep going up and up and up in a more or less straight-ish line. You got some growth spurts in there, but pretty close to a straight line. But eventually, it's going to stop doing that because you don't just keep growing forever. So somewhere around, 16, 18, whenever you stop growing, that's actually going to level off. So this graph of a nice straight line is really only going to be good for so long. So not everything is linear forever, and we'll get into a little bit of that later on of what do you do if it's not going to be a straight line forever. The ones in this section, they're all going to be nice lines. And that is pretty much what's going on there. So go ahead and check out the homework in the description, and I will see you next time.